So let's take a look at another one of these systems of inequalities, right? Now the goal is we're going to graph both of these, and we're looking for the region where both inequalities overlap. So let's take, here's my axis I'm going to put my answer on. All right, we'll take the first guy. Y is greater than x minus 7. Before I go anywhere, what do you think? Solid or dotted?
It's
Dotted? Jason? No, dotted line? Okay. Because there's no line under it, so make a dotted line. So it's a dashed line. What's my slope? 1 over 1. And where am I going to start my graph? At negative 7. So 1, 2, 3, 4, 5, 6, 7. There it is there. And I'll follow a slope of 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, and then I make a dotted line through those. Now what's kind of neat about this is for what you're supposed to be able to do, we're not really too much worried about accuracy about where the lines cross. This isn't like section 1 where it was all about making sure the two lines cross and pick that point out. We're more looking for the region, so you get a little more leeway to kind of fiddle a bit. Which side do I shade on? Do I shade towards or away from 0, 0? Away? Let's see. Is 0 greater than 0 minus 7? 0 is greater than negative 7. So we shade towards 0, 0. Now I'm just going to, again, very light with my lines, just a reminder of which way I'm going, because I don't want to get where I can't see my graph. Now let's go ahead and we'll try, let's use some red, jumps out a bit better. So 3x plus 6y less than equal to 12. Now I can't graph that as it is. I have to get it in the slope-intercept form. So take away that 3x from both sides. Leaves me 6y is less than equal to negative 3x plus 12. And then divide by 6. Remember, everybody gets divided by 6. So y is going to be less than equal to negative half plus 2. Remember, the negative half is from 3 divided by 6. And the 2 is 12 divided by 6. So from this guy, what do you think, Grace? What's my intercept? 2. Yeah. Somebody else. How about my slope? Miriam? Negative 1/2. So I start at 2. 1, 2, right there. Start at the intercept, and I follow the slope. Down 1 over 2. Down 1 over 2. Solid line or dashed line? Solid line, because there's a line under it. So solid line. Now I got to figure out which way I'm shading. What's going to happen when I put in 0, 0? Do I get a true statement or a false statement when I put 0, 0 into this equation? 3 times 0 plus 6 times 0, is that less than or equal to 12? Yeah, I think it is. Which I can do the same thing here, too. 0 less than negative half 0 plus 2. 0 is less than or equal to 2. So in either case, it checks out. So I'm going to shade towards 0, 0. Because if the test point works, you shade towards it. So here are those lines. So it's going to be this way. And then I look for the area where both of them overlap, where I have green lines and red lines.
What if they don't overlap?
They will. And, well, actually, I say that. If they don't overlap, then your answer is no solutions. There's no overlap. It's the red one is shaded towards 0, 0 because it worked. And the dotted line is shaded towards 0, 0 because it worked. So the area that both work are all through here, in here, all of these, and all of these.
I have a question.
Yeah.
Why don't you just shade both, or put both lines on the graph and then figure out what they work and then shade it? Because it's so much less confusing.
That'll work too. Yeah, you can do that. You can draw your lines and then say, okay, let's try this point, which is in this area. Does it work? Try a point up here, try a point over here, and a point over here. That'll work.
No, like, you put both lines on the graph.
Yeah.
And then you test both of them for 0, 0. And then you find it.
Oh, and then you go from there.
Yeah.
Yeah, you can do that.
Why don't you do that?
I don't know. I don't. I like lots of shading, so I kind of like lots of things to look at. Although I will admit this, what I used to do, find a piece of scrap paper here. When I was first learning this, let me redraw this real quick. I might have done this when I did it. So there's that line, and here's this solid line. I might have just done this. Rather than actually shading it, draw a couple of arrows to show which side I was going to shade. And then I kind of look, where's the area where the arrows are all pointing? Oh, it's this region right here. You could do that too. If you don't like lots of shading on the page to get confused with. You know, if you've got some decent colored pencils or crayons, you can even get away with going ahead and using like a light color and then a contrasting light color, and then you look for where the two colors blur, like blue and yellow. And then where the two colors merge, that area will automatically kind of pop out as kind of greenish. And could somebody please stop fidgeting? That chirping noise is going to drive one of us crazy. Thanks. Apologies to whoever has the chirping chair. Okay, what more can I say about this particular problem? Guys? Shh. Yeah. If the line goes through 0, 0, you're going to have to find some other test point. Like 1, 1 is a good test point, or 1, 0. You want to keep small numbers and keep them simple. So like 1, 1's a good one, or 1, 0, or 0, 1. One of those right there near the origin, and you should be safe from there.